This del cross H bar is equal to JC. Actually, it is a J bar. The J bar is the modified JC plus JD. JC plus JD bar. Okay. This is a uniform plane wave. Uniform plane wave in free space. The first topic in the third unit. Using the second Maxwell's equations, modified Ampere circuit law, and take the del cross H bar is equal to J bar, that is a JC bar plus JD bar. In the free space of the perfect dielectric, in the free space, the perfect dielectric J bar is equal to 0. Perfect dielectric means there is no any conductivity. Okay. The sigma by omega epsilon is very much greater than less than 1, and sigma by omega epsilon is very much greater than 1. Sigma is very much less than the epsilon value, means it is a perfect dielectric. This perfect dielectric. Okay. And sigma is very much greater than the epsilon 1 is a perfect conductor. Perfect conductor. Okay. Means here the sigma value is comparing with the epsilon. Comparing the epsilon, the dielectric is a conductivity. Epsilon is very much greater than the sigma here. So perfect dielectric. And in this condition, the sigma is very much greater than the epsilon value. It is a perfect conductor. Conductivity is more here. Less of the dielectric, and here less of the conductivity. So practically there is some value, but ideal condition we can take it as a 0 simply. So JC bar means the sigma into E bar. This is a formula for sigma into E bar plus JD bar. That is JD bar is a dou by dou T of D bar. That is a Maxwell's equation actually. See, when we consider it as a perfect dielectric means what is the sigma here? The sigma is a 0. The 0 value plus dou by dou T of D bar. Dou by dou T D bar. So when it is a perfect dielectric, since sigma by the omega epsilon is very much less than the 1, this is considered as a perfect dielectric free space. Free space is nothing but dielectric only. We are finding out the uniform plane wave in the free space, in the dielectric only. So dielectric is there is a conductivity is a 0. So dou by dou T of the D bar. So del cross H bar is equal to the dou by dou T of D bar. That is a D. Now I can assume that D bar having with the Cartesian coordinate system is in the x-axis and the y-axis and the z-axis. As of the terms, the dou by dou T of D bar is equal to component of along the x direction is dx bar plus the component in y direction is to dy ay bar plus the component in the z direction, the dz and az bar. Okay. I assume that the d bar is in the Cartesian coordinate system having the components dx, ax and dy, ay plus dz AZ bar. Okay. And del cross H bar as if can take as a del function, del or det AX bar, AY bar. This is del cross H bar. Okay. And AZ bar. So to buy, and I'm writing the del. Do by do y and do by do z. Okay. Do by do z. And the h functions or the components of h is hx, hy, and the hz. Okay. So right hand side we got the do by do t of the d bar components, dx, dy, dz, and in the left hand side del cross h bar is equal to, I can write as del or det ax bar into dou hz by dou y minus dou hy by dou z, and minus ay means you can cancel these lines horizontally and vertically, and can multiply the dou hz by dou x minus dou hx by the dou z. Okay. I can write that equations in the next page. So I'm writing the del cross h bar is equal to ax bar into, okay, dou by dou y hz minus dou by dou z hy. Okay. Minus the second term, you can take it as a negative ay bar into dou by dou x hz minus dou by dou z into hx. This is the equation. Okay. Ay bar is equal to dou hz by dou x minus dou by dou z into hx. And the last term is multiplied with the az bar into, you see here, you can take these, cancel off these lines, dou by dou x of hy minus dou hx by the dou y, dou hx by dou. Okay. So dou by dou x of hy minus dou by dou y of hx. And this equation is equal to the right hand side, we have the dou by dou t of the d term. The d bar as dx to ax bar plus dy ay bar plus dz and the dz bar. Okay. Now here remember to that whenever an electric field is in the x direction and the magnetic field is in the y direction, both the fields are not varying with respect to the x and y. And these fields, what is that field, sir? Electric field and the magnetic field, which are not varying with x and y. Not varying with x and y. Varying means dou by dou y is varying with respect to y. Dou by dou x, it is with respect to the x. It is not varying with respect to y and with respect to x, and with z only, means dou by dou z only, it can vary. It is not varies with respect to s. It is not varying with respect to the y. It can vary with respect to the z only. Means wherever the dou by dou y and the dou by dou x is there, that value is a 0. And we have only the dou by dou z because it is a varies with respect to the z and the electric field and the magnetic field. So in this first ax bar coefficient, ax bar into, so it is not varying with respect to the y. This term becomes a 0. Okay, the 0 minus, it can vary with respect to the z. So dou by dou z of hy minus, and ay bar coefficient, you can see, and it is not varying with respect to the x also. The first term here is also 0. 0 minus dou by dou z of hx, and see the az coefficient, both are in the with respect to x and with respect to the y. So plus az bar, and it is not varying with respect to the x, and it is also not varying with respect to the z. Both of the zeros are. It's a 0. And is equal to dou by dou t of d bar. So d bar is the components having dx, dy, and the dz. Okay. The third term is a 0, and we have only the two terms are there. That is a minus dou by dou z of hy ax bar, and here the minus into minus is a plus. So dou by dou z of hx ay bar is equal to dou by dou t of dx ax bar plus dy ay bar plus dz az bar. To compare here, in the left hand side and the right hand side, in the left hand side we have only the x and y terms. In the right hand side, x, y, and the z. There is no any z in the left hand side. No need of the dz, az bar, dou by dou t. And see, hy, whatever the hy is there, it's not varying with respect to the x. Hy is not varying with respect to the x values. And also, hx and the hz is equal to 0, because in the y direction, because in the h is in the y direction, hx and hz is equal to 0. And e, here you are taking the h value. If you can take the another e value is there, the first Maxwell's equation, del cross e bar is equal to minus dou b bar by dou t. In that, the e is in the x direction, e is in the x direction, and ey and the ez is equal to 0. Ey and the ez is equal to 0. So since it is a h bar is in y direction, since h bar is in y direction, hx and the hz both are the zeros. So hx, what is the hx here? It is in the x direction. The first term, whatever we have in the left hand side, that becomes total, it is a 0. 0 minus dou by dou z of hy, and this is in the ax bar direction, is equal to, now the ay bar direction is not there, and AZ bar is also not there, you can equate the term in the right hand side, dou by dou t of dx, dou by dou t of dx. So the comparing of AX bar and the AX bar. And here, because in the H is in the y direction, it is not varying with X, Hx is equal to 0 and Hz is also 0. We take the two conditions, not varying with respect to X and Y. So we got it is a dou Y, dou X, dou Y, and the dou X is a zeros. So very important here. Since the H is in Y direction, H is in Y direction, so Hx and Hz is equal to 0. So I substitute the Hx here as 0 and dou by dou z, it is varies with respect to the z and it is not equal to the Hy is not equal to the 0. So minus dou by dou z Hy is equal to dou by dou t of dx. Okay. I am changing that b as in terms of E, dou by dou t of dx is epsilon into Ex. Epsilon into Ex. So now you can see here, you can keep it that is a E bar and it is a H bar. Okay, when it is a vector, otherwise there is no any direction is there. So no need of this one. Minus dou by dou z of Hy is equal to dou by dou t of epsilon into Ex. Epsilon into Ex. Or otherwise, we can write it as dou by dou z of Hy is equal to, here already the minus is there in the left hand side, now I'm writing in the right hand side, minus epsilon dou by dou t of Ex. The one equation. By taking of the modified Ampere circuit law, del cross H bar is equal to JC plus JD. When we are writing in the free space, uniform plane wave in a free space, conductor is a 0, the JC is equal to 0, del cross H bar is equal to dou by dou t of D bar. And you can write as a D bar as a components of in the Cartesian coordinates, dx, dy, and the dz, and apply that cross product for the del cross H bar. In that, can use the two conditions. In this, it is not varying with respect to because of electric field is in the x direction and the magnetic field is in the y direction. It is not vary with respect to the x and y. It can only varies with respect to the z because it is in the z direction. Since the magnetic field is in y direction and the hx and the hz, the remaining two components are the zeros, hx and the hz. Using that conditions, finally we derive the expression of the dou by dou z of Hy is equal to minus epsilon dou by dou t of Ex. It considered as equation 1. Another Maxwell's equation you can take now. That Maxwell's equation is a Faraday's law. The first Maxwell's equation. What is a Faraday's law? Del cross H bar is not H bar, E bar. Del cross E bar is equal to minus dou by dou t of B bar. Dou by dou t of B bar. What are the components of the B bar? In the Cartesian coordinate system, dou by dou t of Bx, Ax bar plus By, Ay bar plus Bz and Az bar. Okay. And here also you can check the conditions. The electric field in x direction and the magnetic field in y direction, it is not varying with respect to the x and y, even in the magnetic and the electric field also. But another difference here, in previous to find the equation 1, the h is the y direction, hx and hz is equal to 0. But now the E is in the x direction, Ey and the Ez is equal to 0. Ey and Ez is equal to 0. Ey and Ez is equal to 0. And it varies only with respect to the x. Okay. So del cross E bar, again you can take the det. Del is Ax bar, Ay bar, and Az bar, dou by dou x, and dou by dou y, dou by dou z, and Ex, Ey, and Ez. Okay. Same equation, what we have here, finally, after substituting the, instead of h value, there is E is there. Dou by dou z of Ex Ay bar minus dou by dou z of Ey Ax bar. Okay, Ey Ax bar. Similar, instead of h, I replace the E. But only the one difference is there here. The difference is hy, not the hy, Ey and the Ez is equal to 0. Ey and the Ez is equal to 0. Means the second term, whatever we have, that is a 0 there. After the applying that is a det, the final answer is, you see here, dou by dou z of, that is a dou by dou z of Ex Ay bar, Ex Ay bar minus, and here the dou by dou z of Ey, dou by dou z of Ey, and Ax bar is equal to this equation. Okay. So with respect to the z terms only we have remaining, and with respect to x and with respect to y, both are the zeros. And here Ey and Ex, since the electric field is in x direction, the y and the z becomes a 0. So second term is a 0. So dou by dou z of Ex and Ay bar only. Ay bar means, what is the Ay bar coefficient here? Minus dou by dou t of By. Minus dou by dou t of By. Okay. And the B in terms of mu and H, minus 1 by mu dou, not the minus 1 by mu, B is equal to minus dou by dou t of By is a mu into H1. Mu into H1. I'm writing the second equation here. Dou by dou z of Ex is equal to, now the minus mu into dou by dou t of, not the dou t, this one, dou z, dou z, dou by dou t of H1. So equation 2. I got the two equations. Observe the, you can observe in the left hand side, we derived from the Maxwell's equation, second Maxwell's equation, modified Ampere circuit law. the magnetic field dou by dou z of Hy, because it is in the y direction magnetic field, and E is in the x direction with respect to the z, dou by dou z of Hy and dou by dou z of Ex is equal to epsilon into E, dou by dou t of E. Left hand side the magnetic field and the right hand side is the electric field. Now similarly here also you can see the electric field is equal to the, in terms of the magnetic field, y direction minus mu into dou by dou t of Hy. Okay. Now using these two equations, dou by dou z Hy and dou by dou t of Hy, dou by dou t of Hy, the one and the two equations, you can derive the another equation to see the dou by dou z with respect to z. One thing is Hy and another one is a dou by dou z of Ex. The magnetic field is equal to the electric field, that is dou by dou t of Ex, and electric field is equal to the, in terms of magnetic field, dou by dou t of Hy. Okay. Now modifying this equation as dou by dou t of not the dou by dou t, dou by dou t of Hy is equal to minus 1 by mu into, I'm cross multiplying this equation, dou by dou z of Ex, dou by dou z of Ex. See in the left hand side in this equation and in this equation, dou by dou z Hy, dou by dou t Hy. Okay. Multiplying these two equations, dou by dou t of dou by dou z Hy is equal to, so I'm taking this equation and with respect to the t I'm applying, so this equation becomes of, you see here, this equation becomes of minus epsilon into, already we have the dou by dou t, and now I'm applying that with the dou by dou t again, so dou square by the dou t square Ex. Okay, that is the third equation. Okay, my dear students. Now I'm taking this equation and applying with respect to the z, dou by dou z of dou by dou t of Hy. I'm taking this equation, the second equation, and with respect to the z, taking on both sides. So minus 1 by mu into, here the dou by dou z is already there. So the second derivative, dou by partial derivative, dou by dou z square into Ex. So equation 4. Now as you can see, these two equations in the left hand side both are equal. Dou by dou t, dou by dou z, dou by dou t, dou by z, dou z into Hy. Now equating these 3 and 4, the right hand side, minus into minus minus get cancelled. Epsilon dou square by dou t square Ex is equal to 1 by mu dou square by dou z square Ex. Okay. And now we take this epsilon here. So dou square by dou t square Ex is equal to 1 by epsilon into mu. This is the one equation here. Dou square by dou z square into Ex. And this function, whatever we have here, that is a ballast. V is equal to, that is a V, the velocity V is equal to, in terms of permittivity and permeability, and therefore the V is equal to 1 by, that is a square actually, here also the square and here also the square, I am taking that is under root of V square is equal to mu epsilon, or V is equal to 1 by under root of mu epsilon. The equation. The velocity of the wave, or wave velocity. Wave velocity, or the wave, the propagation velocity of propagation, or it is a wave velocity. And we equating the equation, dou square by dou t square ex is equal to v square into dou square by dou z square into ex. That v square is equal to 1 by mu epsilon, and v is equal to 1 by under root of mu epsilon. So mu and the mu naught in the free space, mu naught is 4.10 to the power of minus 7, epsilon naught is equal to 8.854 into 10 to the power of minus 12. After calculating this equation, we'll get 377, or the eta value is 377, and the velocity is equal to 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second approximately. We already know the V is nothing but the C is equal to capital C. The C is 3 into 10 to the power of 8 meters per second.